print out the Wi-Fi password for everyone who's people will ask for Wi-Fi. Just for the Wii. What's it work? I think it's capital P at. What do you want? Do you want it just presented or?
Yeah, it should, present, it should go automatically. In the first slide, you should see the Wi-Fi. Is there once this is finished?
Say something how you would say it when you say something.
Hello there, yes, and I'll be talking about the Microservices Meetup here in London. And is that loud enough? I'll probably not be much louder.
Why don't you just put it on? It's actually possible.
This is perfect. You listen on the other side. Blah, 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 blah.
Yeah,
People will
we're
be
talking.
silent at some point anyway, so hopefully people won't talk during the talks.
Okay.
Right?
Yeah, put it on that slide so you can see it. Okay. And then it will keep on. That's fine. Is a pub you'd like everyone to go to?
The Eagle is probably the best big pub around here.
Like this? Oh, did you spend like 10 minutes?
Yes,
Sorry.
I spent 10 minutes.
Didn't realize.
This is fine. Okay, this.
Right, okay.
There's more seats at the front here, if anyone
Yeah,
wants to
there are
sit.
loads of seats. All right, cool. Welcome, everybody. I am Dario. I'm one of the organizers of this meetup. I'm going to be emceeing tonight. I think that's what it's called. I don't know. Yeah, so tonight we are going to have 2 talks. Same as usual, we do this every month. This time the second talk is going to be slightly longer than usual, but the format is always the same. 2 talks, half an hour the first one, 50 minutes the second one, and then you have 10 minutes for questions after each of the talks. It's also going to be a 5-minute break in between. Yeah, so I also would like to thank Technovo, especially Dom, for setting up the live stream. This is the first time ever we have a live stream, which is very exciting, so thank you, Dom, for setting it up. And obviously Signal for giving us all this nice food and drinks. And yeah, so Ollie, do you want to say something about?
Very quickly, my name's Ollie. I work for a company called Technovo. Some of you would have seen me standing in the front of these rooms a few times now. Many of you would have met my colleague Dom before at various meetups. We're a recruitment company, but we're a very community-led recruitment company. We're heavily involved in helping to organize events like this. We believe that we should have a more symbiotic relationship with the tech community, and we really enjoy being part of these things. If you'd like to learn a little bit more about what else we do, of course, you can find our website or grab Dom and I for a chat. We're always happy to have a chat. We hope you will enjoy your evening.
Oh, thank you. Right, I'm going to pass the ball to Sam and Hugo, who are also going to speak about fire exits and all that sort of stuff, I believe. Yeah, cool. Thank you.
So yeah, welcome to Signal. These are our lovely offices. The general housekeeping, fire exits are back out the way you came. There's toilets out there. They're all unisex toilets, so make sure that you use those. If you need to, I think there's another fire exit just around here if that so arises, but hopefully it won't. Of course, we're hiring, like most tech companies in London, but yeah.
Cool. So I guess introductions first. My name's Sam, and I work in the infrastructure team here at Signal. I get to work with our sort of data scientists and product on solving interesting problems and keeping up to date with AWS, where all of our infrastructure is hosted on, and keeping on top of security and things like that.
I'm Hugo. I'm a software engineer in the product team here at Signal. I work in a full stack role, so sometimes working with Sam and our other infrastructure engineer around looking after our applications in production, as well as in a back end and front end kind of role. So yeah.
Cool. Firstly, can everyone hear us? And are we speaking loud enough? Is that all good at the back there? Cool. Right, so we'll get started. Open tracing in AWS. So firstly, hands up, who uses AWS here? Yeah, excellent. And who here uses some form of application tracing? Whether that's local or whether it's distributed tracing. Okay. So hopefully this talk will give us a good overview of what open tracing is and how it can help us, and I'll talk about what we'll really get into in the detail in the problem in a moment. So firstly, yeah, this is what we're hoping to get out of this. If you don't know about it, it can help you solve what problems it can help you solve, and if you do know about it, like a more deeper understanding of Jaeger and how to set that up in ECS, and then a bit more of an understanding of how to write that code in a production environment and trace in a production environment. Cool, so firstly, what does Signal do? So we extract insights from the world's media and help professionals make the best possible decisions. What that means largely is on the left-hand side here, this is blurry deliberately because it is our working operational diagram. So on the left here, we have all of our content that we ingest in. It's all of our news, and then that all gets put into one place. It all gets put into the same format. In the middle there, you've got our data pipeline where we augment. We use lots of natural language processing techniques. We use a few sort of neural networks to do sentiment analysis and quote detection, and our clients can train models to understand topics that are interested to them. And then on the right-hand side there, we've got our main product, which looks a bit like this. So a single-page web application where our clients can find insights about things that are of importance to them. So you can look at quotes. We've detected key spokespeople here, and there's sort of a big spike in interest of news on Saturday the 3rd, and that's what our clients would use and think. What problems do we have? So sometimes logs fail us. Sometimes we obviously make Elasticsearch is our brain where we keep everything, and we run a big Elasticsearch cluster. And sometimes we ask it to do something hard, and then it falls down a little bit, and we wonder why. So where has this request come from, and is it linked to any other requests that have happened at that same time, any other databases or services? So the more general problem then is how do we monitor and trace communication between and within a large number of services and databases? So that's a general problem, and this is open tracing. This is what it attempts to do. It's a standard framework to profile and monitor communications between microservices. So it makes a standard way for that communication to happen, and it lets us pinpoint failures and bottlenecks for poor performance. We'll link this slide to everyone at the end of the meetup, so all of these links and stuff that we talk about, you'll be able to get whenever. And specifically, if Hugo, how does that context get passed, and what does that mean?
So within the context of an application, you create spans to kind of represent units of work, and you can attach then more context to these units of work, and we can pass information around about these spans across service boundaries, so that we can do this tracing across multiple different services. So this is the example that they give, I believe, on Jaeger's website. This is what it kind of looks like for us in some of our production services. So we can see this is tracing through 3 different services. At the very edge layer, we have a GraphQL server, and it's responsible for then fanning out and making requests to multiple other different services. It makes a single request here to what we call the Monitor API, which does authorization, which then in turn calls out to our organization API to get more information about that user, and it then makes 2 subsequent requests to our organization's API again, and kind of brings all of that data back up together to return to the client just the data that they need. In terms of, in practice, how that works in JavaScript using the Open Tracing library, there's a lot of libraries out here that kind of give you a lot of this for free. The Express Open Tracing library is the one that we use here. It's very easy to kind of get started with this. It does most of what you would expect out of the box. The middleware provides, it will create a span at each point that an incoming request comes into the server, and that span will get finished when that outgoing, the response finishes going back to the client. However, that kind of tracing on its own within a single service, tracing that request doesn't give us a huge amount of context. The more information kind of comes from when we share that context across our service boundaries. So if we want to make an outgoing request, it also provides a way for us to serialize that span. So on our request, we have access to this span that the middleware has created, and it then provides, we have a number of different HTTP header formats that we can use and inject this context of the current span into the headers of the outgoing request that can then be picked up and traced again. There's a number of different headers here that are supported. Open Tracing has its own standard. Zipkin has its own standard, and WC3 is trying to standardize another set of headers again that will likely be supported if that proposal gets accepted. But the important thing to kind of note here is that the headers in these HTTP services are how we share that context across different service boundaries. So here's an example of then using the headers. It's quite simple. We just add them like you would if you would send HTTP headers across making any HTTP request.
Cool. So what solutions are there out there that will help solve this problem? There's quite a few on the block, and we've a quick summary of some more popular ones. If you're in AWS, you've probably heard of AWS X-Ray, and that does a similar sort of thing. It passes this context around in headers in its own format. It's obviously built into AWS, and so it's definitely got a good integration with AWS. However, you're also locked into it then if you decide to move your services elsewhere, and it's got a limited amount of customization of those headers. It doesn't follow the Open Tracing standard, so that's some of the limitations there. At the other end here, we've got some of the behemoths that exist, like New Relic, Dynatrace, and Elastic APM. These are the sort of the full application performance management solutions that generally are quite expensive, and they're kind of like using a sledgehammer to hit a small little nail into a bit of wood. They're very big. They auto-magically do a lot of the things we're going to be talking about, but they definitely have their own set of problems, and they were too much for us at this point in time. So, in the middle here, we've got the open tracing solutions, which is Jaeger and Zipkin, which are two of the more popular ones. They both implement the open tracing standard, and they both have quite a low memory overhead, so for the infrastructure that's behind it, it's a good thing. So Jaeger itself uses UDP, so it's production ready, and it's very lightweight. It supports a lot of languages out of the box, which Hugo will talk a little bit more about. Node.js, but we use Clojure. We have our own implementation of that we use. It supports Python and Go, all out of the box. Jaeger also has a differentiated sampling. So you might not want to be able to sample every single one of your traces. You might just want to have a few of them. So this gives you methods of doing that. You can either do it probabilistically, or you can do it with a little bit more nuance of which traces you want to actually, you're interested in. And again, Jaeger is written in Go, so it's a very, very small memory footprint. So that's a good overview of what's out there. And I'm going to talk a little bit now about the infrastructure side of how we can set up Jaeger with ECS. I know there's lots of solutions out there for Kubernetes and things like that. We currently use ECS. It's very, very good for us. It does everything we need it to do as an orchestration platform. So this is talking about that. This is straight from the Jaeger website. This is a sort of an overview diagram of what you need to have in place for you to be able to start doing this. The big thing in the bottom, the green thing, is a data store. Where are we going to put all these spans once we've collected them? I'll talk a little bit about that. We've got a Jaeger agent here in the bottom left-hand corner. Now that needs to sit very, very close to your services, because you don't want to spend lots of overhead writing to something that's far away. You want your services just to write very quickly over UDP to a local service. So we want to have a Jaeger agent very close to every service. And then on the right there, we've got a UI, which we want to have, and that's the Jaeger query UI, and that sits and queries Elasticsearch, which is, the data store. I'll talk about what it is in a little bit. It queries the data store and lets you do a bit of analysis about those queries. And those screenshots you've seen are from that UI. Cool. So where do we store everything? We've chosen to use Elasticsearch. You've got these options if you want to use Jaeger. We use Elasticsearch for the backbone of everything we do at Signal. We run our own Elasticsearch cluster. We manage that in-house. We, however, found that the hosted AWS Elasticsearch option is a very, very good option for this. Very easy to set up, and it's fire and forget. We've had no problems with it so far. Very easy to scale it. You just put a few more pluses and pay a bit more with your credit card. So this is our ECS cluster. It's a little snapshot of it, and this is a little bit more of an overview of how we would set this up in ECS. We want to run our agent as close to every service as possible. So we want that agent running on every single one of our EC2 instances in the cluster. We want to have our collector sitting somewhere on the cluster, it doesn't matter where, hopefully highly available between two availability zones, and we want our query to sit there as well. So now I'm going to talk about a little bit more how we set those three things up with ECS, and cool. So the agent. Thankfully, ECS has got a great scheduling strategy if you've played with it before. It's called the daemon scheduling strategy. If you use that, then you can, ECS agent, which is the orchestration manager that manages ECS, will then ensure there is one of these tasks running on every one of your instances. What that then does, exposes these ports, the UDP ports that we need to write to from any of the applications we want to write the traces from, and that will be written to that IP address there, which is the default Docker bridge IP. So that's a bit of a caveat there. If that changes, if ECS changes how that default bridge network gets set up, that might need to be altered. And then this agent then needs to write spans to the collector. So after you've written to it locally from the service, it will collect them in a very clever way, batch them, and then it's going to write them to the collector. So the collector needs to sit, it needs to be load balanced because we want it highly available, and a normal application load balancer won't be able to do this. So we'll need to use a network load balancer, and that's then going to expose these ports here, which is the agent will write to, and it will then balance those ports and ensure that the agent will be able to write to one of the collectors at any point. One of the caveats here is that you, when you want to run behind a network load balancer in ECS, every one of your tasks needs to have an elastic network interface. So if you use the port routing method, you will have ports mapped on an EC2 instance. For this case, you will have its own IP address in your VPC. So There's a limit to that in Amazon. If you've ever hit up against that limit, that might be a bit of an issue here, but that's one thing to look about. The collector is also where we start the sampling strategy. So we mentioned a little bit about Jaeger having this differentiable sampling strategy, and here is where you can set a general way of how you sample. You might want to sample every 2 requests. You might want to sample all of your errors regardless. That can all be set up here in the configuration for the collector. And then that writes to Elasticsearch. The final is an application load balancer service. That's a lot easier to set up. That uses the port forwarding, and then this UI is then used to analyze that Elasticsearch cluster and what you saw the screenshots of. If that was all too fast, this is a link to a repository that we've made open source here, and this is how we implement it in Terraform, how I implement those 3 things. So if you want to have a little bit more information about the nuance of that, you can check that out. There's also a local Docker compose, which if you run that up, then it will emulate what the EC2 instance is very close to that. You'll have all 3 services running on your local Docker compose file, and you can look at how they talk to each other, and then you can write application code to the local host endpoint, which this will expose. So that's all there. Cool.
So I'm going to talk a bit more in depth around one of our applications that we use Jaeger quite extensively throughout. We call it the monitoring API because it's the API that supports our main monitoring product. It's a little bit of a monolithic service that's slowly getting split into multiple, more and more microservices. But each time we make that split, it's important that we're able to continue tracing throughout that application and across those service boundaries that kind of that get created. But also being such a large application and doing so much work, we really want to use this to understand in a little bit more depth what is actually happening internally with this application. So here's an example of us just tracing just into this application itself. We can see it does a bunch of different work. If you're up the front, you can probably see that it makes calls out to Elasticsearch 3 times. So this is like one of those insights that we want to know, like for each one of the requests coming in, if it's slow in Elasticsearch, then how slow is it for our end users? Can we kind of correlate those 2 things? But also, how many times do we need to call out to Elasticsearch here, where we're making 3 requests? We're making a first request, which is likely to ask how many documents are there available for this search over a large time frame. And then we're making 2 paginated requests. So we've had to go back to Elasticsearch a second time to get more documents to be able to give the client what they need. And we've seen in other instances where it's gone off 6 or 7 times to Elasticsearch to get more and more documents to kind of to get what it needs to do. And without something like open tracing, it would have been really hard to kind of get that understanding. A lot of the metrics that we would otherwise capture with something like Prometheus, we can kind of average or get percentiles and stuff like that. But here we can see individually for a specific request what actually happened within that application. To make it happen, requires a little bit of work. Unlike some of if you've ever used New Relic, for example, with Rails, you kind of just install a gem and it goes away and does everything for you. Open tracing is not that kind of solution. We need to add it in a little bit more depth within our applications. So the first thing that we need to do, the monitor API uses a HTTP library called Restify, and there's no client library support for it. So we have to write our own middleware. So here we need to do kind of the opposite of what we were doing in the GraphQL server where I showed you before, where we were injecting that context into the headers that were sent across the service boundaries. Here we need to do the opposite, and we need to use the tracer to extract from those headers, again specifying the format, what context are we operating in. And once we have that context, now we can start our own span. We need to give it a name, which we pull from the path, the route that's going to serve this request. And then we can tell the span that it's a child of another span. And now it doesn't matter in this context whether that parent span is from another service or whether that parent is within the same service. It kind of works all the same. Jaeger and open tracing doesn't really differentiate between where the span is being created. Then we can kind of enrich the span with more information. So you can add logs to spans, but you can also add tags to spans, which gives us a little bit more information to be able to search over. By convention, most of the libraries that open tracing supports uses this http.statuscode, http.uri, http.method, and stuff like that. And if we keep that consistency across different services, then it makes it really easy in the UI to kind of search for these. One of the other nice things that we can do around these tags is there is a special tag within Jaeger that if we set this sampling priority to be 1, and this span is a parent span, it doesn't matter what sampling strategy the application is using, this span is, and all of its children's spans are going to get sampled. So if a HTTP request comes in and it becomes a 500 status, then it and all of the work that was performed within this application and across down to other services, they're always going to get traced. And the last thing that we always need to do when we're doing this is when we're finished with a HTTP request, we need to make sure we finish all of our spans. To kind of see what that looks like in terms of those tags and that enriched metadata, you can see that here's an example of some requests that came into the Monitor API, get information about the URL that people have been searching for. We can enrich it with a user ID to understand who was the user who performed this, which then we can correlate back to other things and understand who they were. And we can also see some metadata that Jaeger itself has added around what the sampling strategy it was using at this point in time. However, as we go deeper and deeper into these applications, things start to get a little bit more complex. So the straightforward strategy of passing this context of what is the parent to a particular piece of unit of work, here we're doing it explicitly. So all of our functions that we want to trace deeper into, they optionally take some context. And that context is going to be the span that was the parent that they got called from. Seems a little bit cumbersome and a little bit of a not nice solution, and you'd be absolutely right. However, Node being a single-threaded server, we don't have the concept of something like thread local storage where we could kind of put this and let everything kind of have access to it and not need to pass it explicitly down. I'll talk a little bit more about that in a second, but you can see that we start to add a whole lot of boilerplate as we move further and further down into these applications. If we are past this context, then we want to start a span. We want to start another span where it's a child of the context that we got passed in. We can enrich it again with more metadata. Here we're doing some search. And then as we do our work, we need to create a query for Elasticsearch, search, and process some results. And each one of those pieces of work, we again need to pass this context down further and further, and always finishing that span. So this is a little bit of a pain. There is an alternative that we haven't kind of had the chance to look at in depth, which is Node.js has a concept of continuation local storage. So as you chain together a bunch of asynchronous calls, you can associate some context with that so that all of these functions then have access to that context, but we kind of haven't had too much of an opportunity to explore that in depth and kind of what that might provide to us. So yeah. Closure we also rely on quite heavily. However, Jaeger doesn't support that directly. We have to rely on the Java interop, and the Java API is definitely not as nice and as clean as the JavaScript API. It introduces a few more concepts, including a scope manager, which will manage what is the active scope for a given thread for you. However, this also then starts to fall down when you start looking at multi-threaded environments. If you want to process a bunch of work in parallel, and you have this context associated with that thread, it can be a little bit tricky to manage and make sure that you always have access to the correct context. But ideally, we'd like to kind of turn this, write our own closure wrapper around this to make it a little bit more idiomatic, and like to open source that at some point. One of the other things that we would like to do is, looking at this so far, is just kind of HTTP requests coming into our servers, into our application. But we have a bunch of other event-driven systems around the edges, and can we use this system? Can we use open tracing for these event-driven systems? It's definitely not what it was designed for, but in theory, it seems like it should be possible. Sharing the context across headers is really just a method of serialization. And there's no reason that we couldn't serialize that into some JSON metadata that went with messages across SQS or something like that as well. And we could do something similar then to be able to use this tracing across those different services. However, can we use it for something even more complex around these event-driven systems? What happens when we're processing messages in batch? So we bring in millions of documents a day and we push them through a machine learning pipeline. So what happens there when those services are processing batches of articles at a time? Can we still do that same kind of tracing to understand which services processed an article at which points in time and be able to visualize that when they're happening in parallel. And that's definitely an unknown for us, and definitely something that open tracing wasn't designed for, but we'd probably like to explore at some point.
Cool, yeah. I know that was very, very quick, but hopefully, yeah, you've got a good idea. If you didn't know about open tracing, actually, it's a very good way of solving problems where logs fail us, and we want a little bit more information about the relationships between services. And then if you did, maybe a little bit more about how Jaeger and you set it up, or a bit more about how to use that in Node.js and then some of its limitations. Cool.
Since we have time, we might do a little bit of a demo. Yeah, so since we have a bit of time, we might just do a bit of demo. This is our live production system, and we can see there are a number of requests. We can find one that's interesting. One of these RSS requests, we can see there's 13 different spans that this request has gone through. We can see down here, we can expand out to see more information about this particular unit of work. We can see we were performing search. There were 92 results for this search, and this search consisted of searching for 245 different entities, but excluding 2 of them. We might be able to find an even more interesting one. So the search lets us specify duration. So if we go really slow, something that took more than 10 seconds, none in the last hour, fantastic. Of the last 2 days, there we go. So we've got a facets request here that took 10 seconds, and we'll probably be able to see down here for our instrumented search. So for this search, there were Elasticsearch found 2.2 million documents, which was possibly what contributed to that being quite so slow. But we can also then look at when the original request came in, who was this user? So then we can kind of start to look back and go, what were they searching for that might have been this bad? CSV exports are always slow. Here's a search that took 19 seconds. So here's an example. We can see we've gone off to Elasticsearch 4 or 5 times to get different results. That a single page wasn't enough. We've had to get 4 pages of results from Elasticsearch. And here we've got 4 pages for a total of 300. There were only 350 documents here. So it's quite interesting that it took 10 seconds and probably something we should look into. But obviously, then there's the really bad searches that take 30 seconds and go off to Elasticsearch many more times. But this gives us the ground bed for being able to kind of look at these different things that are happening within our system that a lot of other things that we've looked at just haven't been able to.
Cool, yeah. Any questions? Yeah, go ahead.
The tags, the headers. So the tags are the metadata that we add, for example, here. So these are our own custom tags that we can add onto things. The headers are usually IDs of traces. I think there's usually 3 headers that it adds, one of them being like the parent span, an original one. I think there's 3 different IDs that it shares across in headers. I don't remember off the top of my head, though.
Anyone else? Yeah, go ahead. So the question was about proto-buffers or RTC?
gRPC.
gRPC, yeah, okay, instead of HTTP.
I'm honestly not sure off the top of my head. I've not looked into it.
Yes, go ahead.
You say that you store Elasticsearch. How big is the cluster just to store the tracing?
Okay, so we've got a curation lambda that will clear it up after, I think, 10 days at the moment. So I think it's the smallest Elasticsearch.
I think it's only 100 gigabytes at the moment.
Yeah, 100 gigs. But again, that's very easy to scale up if you need it. Go ahead.
So you mentioned that you need to write some boilerplate to actually instrument those documents. I was wondering if you have a strategy on how you go for your code. Do you instrument everything, log everything, or do you focus on what you think would be the critical tag, or maybe you go after you see some slowdown? Or?
So I think it probably depends on the services. the monitor API being such a large service, we've probably gone into more depth than we otherwise would. Building smaller services, I think we would definitely be looking at what dependencies that service has, and if it needs to make calls out to those other services, being able to bring that context down to the point that it makes those requests so that we can trace across those boundaries is probably the most important thing. Internally within those services, as we build new ones, generally they don't end up big enough that we need to do much more internal tracing within a single application.
Cool. Anyone else? Yeah, go ahead.
So as we do more and more things asynchronously, so I think it depends. The monitor API itself, so I mean, I think you're referring to more around JavaScript and whether JavaScript is fit for purpose, or? So I don't know how much of a difference making things synchronous would make. I think that we possibly still have the same bottlenecks around the event-driven systems. It kind of just gives us a little bit more reliability in terms of being able to move quickly and have the kind of confidence that those events will eventually get processed, whether it's the first time or the third time. The queuing systems, SQS and its dead letter queues and things like that, make sure that we can eventually get things to the state that it needs to be in, instead of exactly when the user clicks the button.
Thank you very much, everybody. Yes. Yeah.
Should we take 10 minutes? 10 minutes?
Just stand here as like doing your thing.
Check, check. Mike, check, check. 1, 2. Check, check. 1, 2, 2, 1, 1.
No, it's just to see if you're.
Oh, so it's going to get the head into the shot this time
Yeah.
instead of just your woodruff.
I thought where that was going was they're all wanky beers. You don't want one anyway. But it's okay.
That's true, they're all wanky beers, you don't want
Hello. Hi, we are ready for the... Hello. Hi. Ready for the second talk?
Everybody fed and water, please take your seats.
Right, second talk, Jamie. You're going to speak about cloud native patterns. If you don't know Jamie, he has spoken in several different conferences and he's written a book or more, and one more coming up. So I think this talk is going to be about some of the things that you're going to talk about in your next book. Yeah, very much looking forward to hearing from you. So, yeah, take it away.
I haven't written a book, books plural. I'm in the process of writing a book now. It's coming out in October, but it's not finished. Hasn't even started. So there's no claim to fame anywhere in there. We'll come into that in a minute. So obviously, we've signed a contract. So luckily, this has not been streamed to the internet or anything. So the publishers won't find out. That was a joke. Okay, the earlier bit was not a joke and I got a laugh, and then that bit was a joke. Okay, right, I'm just going to, moving swiftly on. Thank you ever so much for having me. My name is Jamie. I work for a company called Container Solutions here in London. Cannon Street is our office. Do I need to stay here?
Don't ignore me.
Okay, fine. And Container Solutions do stuff with cloud and containers and Kubernetes, whatever. You can check on the website. Thank you for having me this evening at the London Microservices Meetup. My talk is not very technical, so I really hope I don't bore you all to tears, because I'm nowhere near the league of the gentlemen who came before me. But thanks for having me anyway. It's nice to be out, and it's nice to practice the stuff I'm going to do tonight, because it's all new material. So the bits you like, let me know, and the bits that are rubbish, please, I could probably judge by the look on your faces, actually. But please let me know afterwards. Okay, so what is the one thing I want people to take away from this talk and maybe the book later? Hope. Now, that might be a strange thing to think about here at a talk about technology, but cloud native and cloud native system development is hard. It's complex. The space is full of vendors promising turnkey solutions to problems that we can barely define. Many people that I come into contact with, whether they're techies, middle managers, executives, don't know anything about cloud and cloud native technologies. They feel lost, often they feel embarrassed. So I'd like to restore a little bit of hope to proceedings. The three big takeaways from this talk are basically, the first one is, how can you use cloud native patterns and our pattern language to develop your own kick-ass, badass technology stacks and technology teams. Secondly, I'd like to show people that they're not completely bonkers. Often we get an intuition that something's not quite right and we can't articulate it. I'm hoping in this talk to let people know, if you feel tense or if you feel strange in a situation, that might be your subconsciousness speaking to you. And finally, I want to show some common configurations of patterns that are just bad. They just don't work. They're not a good idea. And I've got some examples that I'll go through, and it could be that you can relate to some of these examples. It could be that you're in the middle of one, and you're looking for a language that you can use to discuss with your colleagues. So fingers crossed, the configurations will show that. So this is the rough agenda. Small introduction in a second. What is a pattern language? I want to hit this quickly and get that out of the way. I'm guessing most of you have come across books like Design Patterns and Patterns of Architecture, Patterns of Design, stuff like this. So it's probably, who's over 40? Come on. Right, so we're in the minority. So you lot all know about design patterns, right? Is there anybody who's a programmer who hasn't come across the Gang of Four Design Patterns book? It's not a trick question. You've all read that book? Okay, yeah. Nobody wants to put their hand up. So we'll look at some examples, and then we're going to look at these scenarios, what I just mentioned, what creates tension. And then finally, I want to try to put patterns into context of cloud native in general, the bigger picture, wider level. So let's get cracking with that. So in 1979, Christopher Alexander, an architect, he released a book called The Timeless Way of Building. And what he did in that book was introduce the world actually to a concept that he called QWAN, Q-W-A-N, the quality without a name. And this is what he had to say about it. QWAN is something that's central to life, to the spirit, to a building, to the wilderness even. It's an objective quality and it's precise, but it's hard to name. Now, such a quality, or more precisely the absence of such a quality, is not usually noticed cognitively, but rather emotionally. So a simple example is if you walk into a room that is just not quite right. So this is from Alexander's book in 1979. On the left-hand side, you see a bay window and seats arranged at right angles to the window. If you were sat in this room, you would feel comfortable. The room on the right, it's what Alexander calls holes in the wall, has got a problem with it. The problem is this. On the one side of the room, there are light sources. On the other side of the room, there's the seating area. You will be naturally drawn to one or the other. So within this room, you will always feel torn. You'll always feel that tension. If you had a house big enough to have an extra room in it, this would be the room that you wouldn't go in. It doesn't feel right. Now, we're not architects, so it would be difficult for us to put names to that, put words to that. So, sorry, I looked too quick there. So when Pinny's my co-founder at Container Solutions, when we started working with our own customers and trying to understand why they were succeeding and why they were failing, we often felt these opposing forces. So, for example, a common pattern was to do with experimentation and learning. So we claimed to be experimental, but it seemed they had chronic learning disabilities. They didn't seem to learn anything new. Now, it's not that they were lying, nor were they confused, and nor were they deluded. But they'd configured their organizations and the way they build and deployed software in such a way as to create opposing forces. The tension that the people in these companies felt was transferred to us. And that came in body language, mixed messages, sporadic or mixed results, and a general feeling, but not always a clear articulation of unalignment. So what happened next? This is about 4.5 years ago. So the next thing we did was sort of drove ourselves a little bit potty, bonkers, for those are both English words actually, crazy. We drove ourselves a bit crazy for the non-English people in the room, trying to articulate these hunches and these intuitions that we had. So in the first instance, that led to the, I say in my notes here, now famous, I don't know if it's famous, the now famous Container Solutions Maturity Matrix for cloud-native technologies and cultures. But however popular this thing is, it lacked 3 key features. So the first one was, it's impossible to capture the temporal nature of transformation. So transformation is a process that requires steps, and almost by necessity takes time. The second thing, of course, is it doesn't do much in terms of fine-grained building blocks. So the patterns language mentions tracing, like in the previous talk, mentions architectural patterns, but the maturity matrix can't do that. It doesn't have an opinion on tracing as it stands, for example. The other thing, of course, is it doesn't show specific elements in common scenarios because it's not fine-grained enough. There is, of course, common problems with maturity models. They've just been addressed on our blog by one of our colleagues if you want to check that out later, because maturity models are very static, right? So those are the general issues. So Pinny and I were trying to piece together this thing. A colleague of ours, Anne Curry, she went off on a bit of a mad mission. She wanted to study companies that had succeeded with cloud-native technologies and companies who had failed with cloud-native technologies. So that became her book, The Cloud-Native Attitude, which is also a pretty popular book, actually. There's 4 spare copies here for people who want them. There you go. So we had this sort of swirling nexus of activities. We had Anne's work, which was a little bit like social anthropology. We had my work where I was doing strategy formulation with businesses and trying to understand their constraints. And then, of course, we had Pinny's work into the pattern language itself. So that was more his than my stuff. And, you know, what happened then is we started to develop our own theory of cloud native. So our observations became hypotheses, and our hypotheses became experiments, which, of course, we ran on ourselves in the first instance, and any of our customers who would let us run our experiments on them. So we're very grateful to our customers and our partners in the community, because without them, we could have never have developed the pattern language, which is essentially a form of praxis. It's the embodiment of the theories we developed put into practice in the real world. So pattern languages are a type of practical tool. So finally, the story is coming to an end. Pinny submitted his pattern language to the PLOP conference in Seattle, and it was accepted, and thus we finally, after 4 years of working on this, gave birth to the Container Solutions Cloud Native Pattern Language. Now, Dario, you're from Switzerland, are you? Are there any other people from Switzerland here? No, you're too ashamed to put your hand up, that's okay. The pattern community is dominated by Swiss and Germans. So for some reason, those countries really like to develop their own pattern languages, a way to classify things and recombine things. I don't know if that's a quirk of the university system there, or if there's extra academic research there, but when Pinny was in Seattle, he was said everybody was a German or a Swiss man or woman. And after the patterns was launched, we then started to piece together the book, and the book is the Cloud Native Survival Kit. It's coming out in October. It's not written. It was nearly written, but apparently last week it all got thrown out, and now it's going to get done again. Pinny has convinced me that these changes are for the best. I'll let you know how we get on. Okay, so, right, what is a pattern language then? How am I doing for time, Dario? Okay, so I'm all right. Okay, so what is a pattern language? Well, a pattern language is like a dictionary with words in it. Yeah, like a dictionary, like a data structure is a dictionary, like a hash mark. Thank you. Thank you for the heckler. So cloud native is a name of a particular approach for building and designing applications, and the objective is to sorry, I'm on the wrong page. Excuse me. Excuse me. Sorry, I've lost where I was. Okay, so what is a pattern language? Yeah. So pattern language is like a dictionary. So a pattern language collects specific design decisions about a specific domain. So the way that it's similar to a dictionary is that if you were to look into our pattern language, you would find problems, they're the words, links to other problems, a little bit like a thesaurus or similar. The proper use of the pattern, that's what we would think of as the grammar, and then finally, how it can be used, namely the syntax. The point, a really key point of this, is that patterns are context dependent. They're not context independent. So if we go back to Christopher Alexander's pattern language, he had a pattern that he called the bus stop. And you could probably guess that that was a pattern for how to get people to queue for a bus. It was collected under a wider heading of places to wait. So another place you might wait is the hospital, but you wouldn't put a bus stop in the doctor's waiting room. So even though they were categorized as areas to wait, the pattern is context specific. In the case of the bus stop, it's about a road and it being outside. And believe it or not, there are optimal ways to create bus stops and suboptimal ways to create bus stops, if you can believe it. Okay, so what is a cloud native pattern language? Well, this is really a collection of design decisions put together with cross-references that specifically addresses problems and design decisions in cloud native computing. So cloud native, the way we see it, is a particular approach to designing, building and running computer applications. So typically the objective is to increase the speed of application development. It's usually not cost cutting. Did anybody move into cloud computing because they thought they were going to save money? Anybody? So where the guys from earlier gone? I love the animated GIF about AWS shoveling dollar signs into the oven. Most people don't move to the cloud because it's cheaper. They move there because it enables them to get to value more quickly. So one good example of this is the Financial Times. Don't know what that slide is, so I'm just going to ignore that. Also don't know what that slide is, so I'm going to ignore that as well. Nah, I don't even know what that subheading is. I get the feeling somebody's editing this. Sorry, 1 second.
Is it the right person?
Oh yeah, it is, yeah. So the Financial Times is a really good example of how to use cloud-native technologies. So about 10 years ago, the board of the FT had two problems. One of them, you could imagine, was more solvable than the other. The first one was that print media was changing. And whilst most people were slowly adapting, the FT started asking themselves, how can we not only adapt and survive, but thrive in this digital marketplace? Now, the FT, as far as I can tell, is one of the only paywalled publishers that actually makes real money, real revenue and real profit. A secondary, and I would say easier problem to solve, was their aging and creaking infrastructure. So the company did two things. So it simultaneously worked on migrating their operations to what was what we would consider a private cloud. They were actually using virtualized machines. So that subsequently changed to AWS. But they also started changing their deployment and development practices so they could rapidly respond to customer demand or data that was coming, or they could launch new products that they could then generate revenue from. So as a result, the FT began to rapidly develop these new features, and their strategy, you will not be surprised to discover, had these three key components. So these are very common elements of a cloud-native tech stack. There's a sort of use of microservices, there's containerization as a way of packaging and then getting the most out of the cloud infrastructure. And then there's cloud services that are either consumed wholeheartedly, or in many instances, people just consume infrastructure as a service. In the previous talk, they compared the different tracing solutions, and you saw X-Ray, it's very much tied to AWS. So the reason many of our customers will only consume public cloud infrastructure and not the services is because they want to avoid that lock-in. So these are the three key elements. So what we think of that is this. When you see an example, when you see an application or a company develop an application where they're deploying in small, rapid iterations with a squad of different independent teams, and those teams are collaborating via an integrated platform, and usually everybody's a little bit happy, by the way. This is when you know you're looking at the cloud-native approach. It's not completely definable, but that is the quality without a name that you can detect. You know it when you see it, and you know it when you know it. You know it when you see it, and you know it when it starts to go wrong as well. So let me give you now a couple of example patterns. The only reason I'm going to show two of them is because patterns are dry as dog shit. They really are a very boring thing to produce. It's terrible if you've got to write a book about them. Because you have to be very specific. You have to be specific in their definition, specific in how they can be used and how they relate to each other. Because if you're not, they cannot be used to construct larger design elements. Now that's the same with words in the dictionaries. You can't half define the word, right? There cannot be any ambiguity. And if there is ambiguity, the context makes sure that ambiguity goes away. So that's why patterns are extremely dry. This is how dry they are. There's only 5 sections to them. There's the definition, and there's the few subheadings. In this context, consequently, therefore, related patterns, yada, yada, yada. The most interesting thing is looking at what happens when you take perfectly good patterns and configure them into perfectly bad designs. That's what we'll get to at the end. Okay, so this is a typical design pattern, business case. When an organisation's leadership does not fully comprehend the advantages, blah, 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 you need to provide a strong business case that will allow them to understand and support the project without hesitation. So you might be reading this thinking, oh my God, what is this guy talking about? We all know you need a business case before you kick off an IT project, but we get paid, in some instances, vast amounts of money to walk into companies and say, oh, you haven't got a business case. And then they write it, and then everything aligns on the customer side. It's a very quick change, and it's a pattern that people forget. Moving along with the pattern then, this is the context in which that pattern will work. So if you are risk averse, if you're trying to minimize uncertainty, if you're change averse, etc., this is where the business case will help you. I don't know if a very strong business case here at Signal for cloud native technologies is useful. I'm pretty sure that all native, cloud native consumers. Signal, have you got a business case for using Amazon and stuff like that? Are you aligned on the management team or the exec team? No, but they all agree with each other, don't they, that it's a good thing to do. So there are some contexts where this pattern's not useful. It's just because there's no point. Therefore, this is what you need to do. You need to create the business plan, and then consequently, this is what's going to happen next. So in the related section for things like business case, there is executive support, transformation leaders, having a strategy versus having a plan, etc., etc. A technical pattern, microservices architecture, you want to reduce the coordination between teams delivering large monolithic systems, and therefore you should build the software as a series of microservices that can be deployed independently. The context will tell you where you can get away with using this pattern, where you can create value from this. It's usually when the monolithic system becomes just a little bit too big for one person to understand. That's one of the key contexts. If there's a lot of pain in the deployment process and you've been avoiding it, that could also be another type of context where you will succeed with this pattern. Therefore, you should split the application up. Consequently, your new system, if you can even believe this groundbreaking research we've carried out, consequently your new system will no longer be made of large pieces, but lots of small pieces, and the related patterns are thus this. These are very important in the case of microservices, because these patterns interact and compound to create greater value together than they could if they were separate. For example, it's hard to have hundreds of microservices if you're not doing automated builds, because you'll find that you waste a lot of time patching single deployments and builds of microservices. So if you could just cast your minds back then to the earlier example of the window in that room that creates all that tension. There are some configurations of patterns that will make you feel tense. This one is a bit of a classic. So this is, of course, the lift and shift pattern. This doesn't work. Lots of people think, you know, a lot of executives, who works for like a big bank or a big insurance company? Yeah? Maybe there's people, who works for a cool startup in Shoreditch? Quite a few of you. I'm sorry that you had to suffer this talk. Lots of executives were incentivized to get to the cloud by 2020. This is not a lie, this is their feedback from the field. Why 2020? Anybody know? Sorry? And well, that could be a reason, but that's not the reason I had in mind. Sorry? He's getting close to the truth. Or something like that. He's sort of on the way to the truth, but there were 5, 3, 2 and 1 year plans. All around the world, we visited customers in the Netherlands, in Germany, in London, in the United States, and nearly all of them had 2020 cloud plans, 2020 vision, 2020, and we investigate, you know, like you do. Correct. The reason they all went for 2020 is because it sounds catchy and it's symmetrical.
I used to work for a bank.
Right? So there are lots of people there with 2020 cloud native strategies. So as 2020 rolled around, is rolling around, they all panicked and threw everything up onto the cloud and said, hey, we're cloud native, lift and shift. Our phone rings more and more and more as 2020 gets closer and closer and closer, which is a good thing for us. So the problem with lift and shift is this. We were working with a bank, I'm not going to say where or when, but essentially what they'd done is they wanted to create a spin-off. They wanted to create a challenger to the challenger banks that they knew were going to threaten them. All banks are nervous about Amazon and Google moving into finance anyway, and so the bank we spoke to wanted to do a spin-off, and they're going to challenge the challenger banks. We've got Starling in London and Monzo as well. So what they did is they took all the best engineers from the main bank, all the processes, they got a design agency, created a new brand, and said, this is our cool new bank. I don't know what it was called. Well, no, that's not true. I do know what it was called. I can't share it. And so they launched, and off they went, building the bank in the cloud. Typing. Boom, 1 year, finished. Great job, awesome. Onboarded a couple of hundred customers, brilliant. Onboarded a couple of thousand, Amazon bills went through the roof. So what had they done? They'd recreated their own massive monoliths from the bank. So without a change in thinking, they'd done what they set out to do, build a bank in a year, but they built their own bank on a cloud that you have to pay for every month. So obviously, if you've got your own tin, you don't need to pay yourself every month. So that was a massive example of taking only one element of cloud native and ignoring the other 8 dimensions. So watch out for that. If you think that lifting and shifting without any re-engineering of your applications is going to bring you much value, you might be in for a little bit of a shock. This is a very common pattern as well. People treat cloud native as an extension to the agile software development methods. The agile software development methods have got a few things in common. They use automated tests and automated builds. Teams work in cycles that usually there's a planning moment at the beginning and there's some sort of retrospective at the end. And therefore, what happens in this scenario is no genuine paradigm shift actually happens. So people throw on a few stories to the backlogs, infrastructure stories, they get Kubernetes going, they get things containerized, 2 sprints later, done, we're cloud native. But what will happen is the following. Microservices get treated as simple extensions of Agile, but they're not. Cloud native relies on a different deployment and delivery mechanism. So switching to a bank that I can talk about, ING in the Netherlands, they did a pretty good job of this. So if you look at the cloud native axis, you see collaborative culture, and you also see teams that use DevOps and SRE principles. So typically, in a proper cloud native setup, teams don't communicate to each other through a product owner who speaks to the product owner of the product owners right the way to the top before putting a story on another product owner's backlog and infrastructure and on a specific team like that. Because if you do that, the cycle time to get your change onto somebody else's backlog is at the minimum 4 weeks, if indeed it gets prioritized. Because if it doesn't, your change will never get made. That's what happens when you try to append cloud native to an agile mindset. So the way ING do it is this. The microservices teams communicate to each other through pull requests or through suggestions on each other's Git pages. If the microservice team don't want to make the change for you, you can fix it yourself, put in a pull request that may or may not be rejected. If it's rejected, then you can fork their repo, and now you've got your own copy, right? That's what microservices is about. There's lots of duplication, but there's also lots of autonomy. It is the open source model for software delivery within your organization. And that is when you go very, very quickly. Hardly any companies get this. They want the Kubernetes, right? But without a release, now, this is fucking crazy. People adopt Kubernetes and other open source technologies. And the point of using open source technologies is to consume other people's work. So you reduce your cost because IBM or Red Hat are fixing something. But then you have a release cycle that lasts a year. So you cannot pick up all the different changes that come at you via the open source improvements or the open source tool improvements. So this is a common pattern. Does anybody recognize this one? There's a few nods. Okay, good, good. Right, spiking challenges. This is a classic. So often you get many different spiking configurations. This one is basically about a rogue technology team. Is anybody in a rogue technology team who's just doing Kubernetes anyway because they don't care? Even though that the rest of the organisation's not doing it? Oh, come on. Well, it's because the live stream's on. That's why nobody's hand's going up. Okay, this gentleman, a very brave gentleman. So there's nothing wrong with this, right? You probably love new technologies, you like experimenting, as do I. So it's quite normal. The problem is if you make localized changes, you containerize your stuff, you get everything in microservices, but you've nowhere to deploy them to. You're not using Kubernetes in production, so you can't, and you're not using the public cloud, so you're not even taking advantage of load balancing or bin packing or anything like that. It can be an expensive spike. Hardly any value will come from it, other than the learning within the team. The real lesson of the spike slide is that you need to move along all 9 dimensions at the same time if you're to get value from all of them, if you're to get value from cloud native proper. Just take a moment now to, I just want to come back to that in a second. So, okay, so patterns and the maturity matrix. So we found it to be extremely helpful to overlay some of the different patterns with the maturity matrix itself. So if we start up at the top, you can see business case and executive commitment. So if I just check my notes now and take a look at Skyscanner, who knows Skyscanner? Who uses Skyscanner? Yeah, many of you use it. Skyscanner's a really nice team. Most of them are up in Scotland, but occasionally they come down to London and give talks and stuff. And I really want to just keep your attention for just a few more minutes while we talk about Skyscanner. So the first one was this. Okay. The first thing was this. They had an extremely strong business case. So online tools, especially e-commerce, retail, flight aggregation, is hugely competitive. They had a real business incentive to go, and I quote, from idea to user inside one afternoon. So the business case was there. The then CTO said he wanted Skyscanner to work at the speed of the internet. So what that means is, if there's a fix in Kubernetes for a known problem, he wants that integrated into production that day. There's a brilliant talk from Monzo from last year's KubeCon in Copenhagen about something that went wrong. They pulled the latest version of Kubernetes, and there was a very strange bug to do with the way Kubernetes interacts with Docker. They rolled back, fixed the changes, made an announcement, and once they got everything working, they took some time to write a public retrospective about what went wrong. So that is Monzo literally operating at the speed of the internet. That's how container solutions operate, and that's how we teach our customers to operate. That was the CTO and the CEO. If you look at Starling Bank, Greg Hawkins does a brilliant talk. He always tells this story, how the CEO, God, I hope I'm not going to embarrass them. Actually, I think he said this on camera already, so I can say it. His CEO would be in board meetings, and she would be approving pull requests in their Slack channels, or giving feedback on product releases. So there was massive, massive executive support is a common pattern. And then the other thing, of course, at Skyscanner, microservice-based, containerized, and orchestrated. So that was an architectural pattern, or 3 architectural patterns that they combined. But, just to quote Stuart, who's the head of engineering there, he said the real kicker was when they took this architectural pattern and attached it to continuous delivery and build automation. And therefore, what had happened is they increased their deployment rate by a factor of 500. So it's not the patterns per se, but it's how you connect them together. Now, if you move down a little bit into the development section, you'll notice a couple of things. Vision first. Now, why is that in the technical section? So sticking with Skyscanner, because the technical vision, these massive iterations, going at the speed of the internet, has got a real connection to the management practices. And if you don't have that open source within your organization, it's difficult to take advantage of them. So there is space in my world, and I think in everybody's world, for strong technical leadership. Okay, how am I doing for time, Dario? 15 minutes. I'm going to need about 5, so I might finish a bit early, but maybe there's some questions. Speaking of business case, so the other thing, of course, that was clear at the Financial Times was that there was also a very strong business case, but there was also extremely strong executive support. So you see these patterns going round and round and round, and if you look at Anne's book, the back half of the book are all the different case studies. And so although you'll see all the patterns there, what you will see is a different configuration, and you will see in some instances not all of the patterns were used. One of the commonest patterns we see is that there's a real existential threat to the businesses. That's another way of saying most companies will not go through the pain of becoming cloud native unless almost their lives are on the line. Because it's a painful transformation, and if most businesses are functioning, why would you do it? So if there's an existential threat, people tend to move. So, in conclusion, I think Christopher Alexander did us a great favour in engineering and maybe in the world by bringing us this concept of the quality without a name. Because in my opinion, it gives an explanation as why our instincts and our hunches are speaking to us, and often we know something's not right, even though we can't articulate it and can't understand it cognitively. We need to learn to understand that. That's part one of the problem. Part two, unfortunately, is trying to change those hunches and intuitions into simple language that lets you explain stuff to your colleagues. We have tried to help people with that by collecting all of our explanations into one place. The book itself will keep growing, right? That's a never-ending project. With the book, we try to do this. We try to firstly look at what different configurations create harmony and what configurations create disharmony, tension. And then number two, we try to give a name to everything. This is because it's our job to help people with cloud-native technologies. And if we can't explain what we're doing and what's happening, and if we can't help put people's work into context, we're not going to be able to do our jobs. It's also quite good fun trying to write about this stuff, because you think it's easy until you start doing it. Another thing about practices, in conclusion, there are no best practices in the world of cloud native, not in my opinion. We are still moving too fast and we are developing too fast. Best practices, don't forget, are by definition yesterday's practices. There is no yesterday in our world. What we have instead are emerging practices, so stuff that is popping up, patterns. It's important, therefore, to let yourself be inspired by people like the FT, Skyscan and Netflix, but you can't copy them. If anything, you've got to copy the experimental processes they've got whereby they reconfigure themselves. So let yourself be inspired, but remember patterns are like words, right? You need words to write your story, but nobody can write your story for you. So just like you need a dictionary, maybe you need a pattern language to help you with your cloud native stories. The destiny is, of course, yours to write, so I figure we should all get busy getting writing. Thank you. Sorry I finished early.
That's all right.
I've never timed it before. Any questions? Sure, they don't have to be. Absolutely, I will distribute them, yeah.
Can I get one of those books as well?
I was going to say, you do want a t-shirt as well? Yeah, all right. What size are you? You look like a medium. So we've got t-shirts for people who ask questions. Medium. Yeah, there you go. And what was your second question?
That was one thing.
Any more questions? Sorry, I'm going to go to that gentleman and then I'm going to come to you. Yeah. Which is? T-shirt size. Right. Okay. Anybody? You can get t-shirt later. Anybody who doesn't want? Anybody got a question other than wanting a t-shirt?
So
Yeah.
I've worked for a bank before,
Yeah.
and you know they effectively want to buy cloud native ownership.
Yeah.
They buy they adopt the Spotify model.
Yeah.
They'll lift and shift to Kubernetes.
Yeah.
Or to AWS, which can say lift and shift to Kubernetes. But they don't keep they expect their development teams to move faster, but they don't give them the opportunity to deal with all the technical debt from the nest they came before. What if you were going into one of those companies? What do you do? Like, what's the first step?
Well, every place is different. But if I went into a specific company where they wanted to move to cloud native, they had the business case and executive commitment, but they were not creating time to improve legacy code and infrastructure, and related to that, creating time and money for training, then that's what we would talk about. So we may or may not get a slide deck out with the patterns on, probably not actually, use the whiteboard, but we would try to explain the gap in the skills where they are now and where they need to be. They can only be fixed with time for training and time for wrapping up legacy, and then we would simply ask the people, the companies, what do you think about this? So to confront them with it. There may be some pushback on costs, in which case we've got some financial models that shows what they're doing is utterly batshit crazy. And that by with some training, you can create space, and then you get this cycle going. One of the most common patterns in the book, I didn't talk about any of them today, is emergent strategy. So how to break your year up into 12-week blocks. We wrote a framework called Hermes, which explains how to do that. This is a common technique that I use to teach companies who have got these problems. 1, 2, 3. Yeah.
So I have a question. I work in a smaller team, and the company, you're always supposed to try new latest technologies. But obviously, because you're a small team, you can't always be updating to the latest version of, for example, Ruby or Kubernetes or something like that. Do you think there's a balance that can strike between updating to the latest technologies, but still keeping up with other infrastructure and so on?
Why can't you update to the new versions?
It takes time. You have to keep up to date with everything that's coming out. And we also have feature work and other things that have deadlines on them that we have to deliver.
Have you got money?
Yeah.
Then spend it. You have a capability gap. You are under. If you've got money and you believe in investment, then hire a few extra people and then spend time doing those things properly. About the software updates, you need to automate that. You need to get some processes built in, because then once you've done it, it's free after that. But if you were financially constrained, then I would say, oh boy, that's a tricky one, because there's only 40 hours in a week officially. And so where do you find the space to experiment? Actually, there's a around the corner there, they've written on the walls. What's written on your wall? Explore, experiment, and execute. So these are 3 very common phases of strategic execution. So when you're exploring, you're trying to understand what's going on, you're trying to learn. When you're exploiting, you're trying to monetize something, and when you're executing, you're going very quickly. So at Container Solutions, we make a separation between little I innovation and big I innovation. Little I is stuff like new libraries, new ideas, stuff you can test quite cheaply. Big I innovation requires bigger thinking and may not work. There's a very good chance it may not work. So you need to think about innovation, you need to think about what are your priorities as a company, and then align them all together. And money in the bank is like bread in the cupboard. Useless. Bread is meant to be eaten, and money is meant to be spent. So does that answer? Yeah?
My question is kind of similar around cloud native. We have components that do similar things sometimes.
Yeah.
What is your thought process in choosing?
So choosing the cloud native hellscape. Yeah. So if you go to am I still up or not? So if you go to the cloud native landscape, it's absolutely massive. So we call that the hellscape, right? So for a laugh once, I did a database, grabbed a database, tracing tool, some stateful thing, and I calculated the number of permutations, and there were more atoms in the galaxy. So there were more permutations than there were atoms in the known galaxy. So the question is, customers come to us and they're nervous, right? But they don't want to look nervous because they're executives and they're paid to look confident. They're also white and called John very often, but that's different story. There's more CEOs called John than there are women CEOs. I don't know if you knew that. That's a fact. Not many. So they come and they say, right, what do we do? What stack do we use? And this is a really classic mistake. Because number one, there is no right stack. Right? There's only a right stack in your context. You right-size the stack through a series of experiments. So at Container Solutions, we've got a very structured method of 5 days followed by 12 weeks. But we emphasize that these is where we build to learn. Right? So we teach customers how to try things, throw them away, try something else. And if it's working in the tech stack, if it's a big company, you then might go out and say to some of your teams, hey, we're implementing this, what do you think? So you experiment your way into the stack. Now I've actually had hooks in sales meetings because they were just about to pull the trigger on buying, for example, OpenShift, and they realised that's not what they need. It's not a tool problem, it's a problem of a process for experimentation. And that way you can have whatever you like. And it's cheap. You don't need manpower, you need brain power. Yes, ma'am.
So once you've actually nailed your cloud native, once you're relatively secure,
Yeah.
what's next? What's the evolution of cloud native?
These are two questions here. What comes after cloud native, or what comes after a company's gone cloud native? Which one are you asking?
You can answer both.
Right. What comes after when a company goes cloud native? Just happy days, isn't it? You just chill out. You just got messages coming in because someone's clicked on one side of your website.
You've got a bunch of engineers that just achieve this.
Yeah. Boredom.
You're going to lose.
Boredom. Yeah. I speak to a lot of people. I know a lot of people who built things, did it. Now what? I remember when I was in my 20s. I was 25, maybe 26. And I was my first big leadership role. So I built KLM's reservation and pricing service layer. So it was a service-based architecture, all the backend was in Java, and I was an extreme programmer. That's how I got started, right? And I did it, and somebody wanted to use aspects, and I was like, aspects, you don't know what regular expressions are, you're going to kill us. And anyway, I got in there, and I went like, fuck, I got the plan working, and then I got that build going, and then after 12 months, as I envisaged it, it all started working. And then I fell into a massive depression because what was my job? What? Like seriously, what was my job? And people would come to that project and say, this is the best system we've ever seen. So what was my job after that? All right? And I know loads of people who succeeded with cloud native and they just don't know what to do. So they get a new job and do it again. Now the second question, what comes after cloud native? Serverless, lambdas, functionless, stuff like that. Yeah, but we... Sorry?
Are they really dear to different paradigms?
I don't think we are. No, I don't think that. I think if you look at society, look at economics, we can spend energy moving best practice forward or moving everybody else towards best practices. What we're trying to do at CS, we're not trying to move the envelope too much on the front end, or we do a little bit. We're trying to drag the whole of humanity to cloud native. Our hypothesis is that the world will be a better place if we don't have people wasting their time manually patching things. But then we
translate that to a business that becomes, that starts to look like M&A activity, that starts to look like, okay, well, we've got an awesome tech stack now, we can go and buy other businesses and redevelop them and make them more profitable and
could be
better places to work.
Yeah, but then of course we create the problem of the data centres and all the CO2 we're producing. So we've got to somehow look at this, what we're creating right now as a community. Any more questions?
What was your favourite BBC Micro computer game, and did having a BBC Micro influence your career?
BBC Micro massively changed my life. So I was born in 19... So the question was, how did the BBC Micro affect my life? I don't know where the question came from, but it's a good one. The BBC Micro, a gentleman called Christopher Evans, he was a psychologist who became a computer scientist, and in 1978 contracted cancer. In the fit of creativity, he wrote a book called The Mighty Micro, and that was optioned by ITV, who were here in our case studies, and they became a documentary, a 6-part documentary called The Mighty Micro. It was so popular, the whole of England went bananas, and the BBC, as a retaliation, commission their own documentary series and a computer. And a computer. So, when I was 7, I got access to a BBC microcomputer in my school. And that's when I learned programming basic when I was 7. My favourite game on the micro was Joust, where chickens knock each other off. It affected my life massively. I'm from a poor family, from the North Hull Council estate, and I got access to a computer, which got me to university and thoroughly changed my life. Good question. Any more questions? Yes, ma'am.
So, we are planning to, we are now doing a lift and shift. So,
Yeah. Good luck with that.
all the applications, so all the applications are containerized and it's kind of running. So it's not sure whether they are running properly or not. So now we are kickstarting monitoring.
Yeah,
so,
good. Yeah.
So it's really a bloodbath. Like we are having almost all the tools in the market.
Yeah.
So, so what would you suggest? Like, I need to do monitoring for the lift and shift.
Who's in charge? Who's in charge?
Sorry, I would not like to say
Oh, yeah, that's fine. So I'll try to get your hands on the deck. Dario will share the deck on the thing, and I've got some PDFs I can share with you. So for each of the patterns and the scenarios, it says, this is what's happening, this is what you can expect, and then the next section is, practically, this is what you should do. Let me send that to you, and then maybe you can find out which scenario matches yours, and what practical steps you can take. But you are highly skilled, and the job market, you know, your skills are in demand. Right? As long as we keep working for maniacs, maniacs will keep running the world. So vote with your feet, right? Container solutions are highly valuable. Yeah. Yeah.
Is there, I want to say, is there a design pattern? But like, is it a common pattern you see where companies, especially with larger, older systems, they continue to maintain those as if, you know, business as usual?
Yeah.
While building cloud native
Yeah.
on top of it.
That is a bit of a pattern. So if you look at the microservices pattern, there was a specific context. Some of that context is related to risk and value. So if something creates a lot of value, but very rarely changes, but it's risky if you change it, just leave it. So we've done stuff, we built like API layers around COBOL applications, stuff like that.
We were doing the same with like a P1,
Yeah.
PL1, like mainframes.
Yeah.
Bank. We were just building GraphQL layers over the top.
Yeah. So I don't think we have a pattern in the book called Leave It Alone, but we probably we could actually write one. Yeah. Yes, mate?
I have a question. So you had a chart, you know, for different repositories, organization, you had development, you had infrastructure. We've been through similar quality through the lift and shift phase. However, I feel that in some cases we actually stack a couple of places, like we went from monolithic to cloud native in many areas.
Yeah.
However, I seem to realize that there's a lot of disconnection. You know, some individuals, you know, are a bit behind, some other individuals are far ahead. And is there something that you could suggest that we could align all of us to remove?
Well, so one of the difficult things to a growing company is by definition a training company. If you move into cloud native, you are growing and changing as a company. So if we can plant a seed out in the heads of our customers that this is inevitable, you will either learn Kubernetes in the next 12 months, or you can go on a 2-day course and get it done with, right? So one of the things we do is these like 4-week boot camps where we do all the training, including microservices for managers, cloud native for board members, because we want that complete alignment, and we will dip the whole organization simultaneously. And at the end of that process, they will have a common language to talk with each other. Businesses don't need to buy this off us, they can do that themselves. So I think in the first instance, realizing that training is a massive part of this, and then in the second instance, just trying to fix it. A lot of companies chase their tails because they don't want to spend 10 grand on training, but they're spending hundreds of thousands on salaries every single month.
Yeah, we want to do others technically aligned.
Yeah, well, you know where to find us. Any more questions? I know people are probably very tired and it's Thursday and you all want to go home. Thank you for letting me test my materials out. And I'm sorry for any hiccups in this slide, but next time it'll be better, I promise.